Hello, good morning, everyone. In the last class is discussion about the study of what is the definitions of displacement and distance and velocity and speed and what is the acceleration, what is the definitions and what is the CGS units and yes, what is the SI units of in this all physical quantities. In this class, that is the study of graphs. Study of graph. See, it is a displacement. That is a displacement versus first graph is displacement versus displacement versus time graph. How to draw the displacement versus time graph? First graph is number one. First one. That is the displacement means what is the meaning of displacement? It is a displacement is a physical quantity. The position of a body changes at particular direction. The position of a body is changes the particular direction. It is a vector quantity. It is a vector quantity. Time period. Time means what? The time taken by complete on oscillation on vibration is called time period. The physical quantities. It is a fundamental quantity. Displacement is a derived quantity. First, how to draw the displacement versus time graph. That time displacement, it is a symbol of displacement is that is a small s. The symbol of the time is taken as small t. Displacement in meter, time in second. How to, that is the displacement is taken as along y directions. The physical quantities, the derived quantities is taken as along y directions. The time is taken as along x-axis. The first graph is for a stationary body. The displacement versus time graph is a straight line. The displacement versus time is a straight line. How to draw the graph? First one is that is the x-axis. First to draw the x and y coordinates. It is x-axis, that is called y-axis. The y taken as that is a displacement along y-axis. The time along x-axis. It is the body is moves. It is a straight line for a stationary or linearly. It is a position of the body A. A is the position of A. It travels linearly. That is a position A and position B. That is a graph of the displacement versus time graph A is a straight line. Or stationary or linear. Okay na? Next one is second graph is when a body is moving with a constant velocity. That means the displacement versus time graph. The displacement versus time graph is an inclined time axis. Inclined means it is a 45 degree. Inclined time axis. Inclined to time axis. That means when a body is moving with constant velocity. Velocity is a constant. First to draw the displacement versus time graph. This is called displacement versus time graph. Time along x-axis, displacement along y-axis. It is the initial position of the body. O is the initial position of the body. It is a projected vertically direction at a body is A. This is called A. The body is parallel to another body. These two bodies are parallel to each other. It is inclined. This is a direction of 45 degree means it is inclined. It is parallel to what? Time axis. Inclined to time axis. That is the inclined time axis. The graph is a inclined time axis. Next, third one is when a body is moving with constant acceleration. Constant acceleration. Constant acceleration. That means the displacement versus time graph is a curve bending upward direction. Bending upward direction. First to draw the displacement versus time graph. The displacement versus time graph. It is the displacement along y direction, time along x axis. The curve is a upward direction. It is the curve is bending upward direction. That is called upward direction. That means when the body is moving with constant acceleration. The body is moving with constant acceleration. Constant acceleration. Or when a body is the displacement versus time graph is a curve with bending upward direction. Is a curve bending with upward direction. Upward direction. Next one is when a body is moving with constant retardation. Constant, fourth one. Constant retardation. Constant retardation. Constant retardation. Retard, R-E-T-E, or retardation. Constant retardation. Constant retardation. That means the constant retardation means that is a negative sign. It is also called the upward direction, means it is a positive direction of the upward direction means it is a positive direction. Or the constant retardation means the direction of a body is moving with this constant retardation means the curve is a bending. It is a negative direction. First to draw the displacement versus time graph. Displacement versus time graph. The curve is a bending downward direction. Downward direction. That is called constant retardation. Constant retardation. That means the negative sign. The slope of the graph is decreases with time. The slope of the graph is decreases downwards with a time. That is the constant retardation. The constant acceleration means it is a increasing the acceleration. Sorry, not increase. That is a upward direction. The direction of the displacement is upward direction. That means called constant acceleration. It is a constant acceleration. Next, fifth one is when a body is moving with infinite velocity. Infinite velocity. That means the displacement versus time graph is a straight line. The displacement versus time graph is a straight line parallel to displacement. Parallel to displacement. That means first to draw the S versus time. It is body is AB is parallel to displacement. Parallel to displacement. That means a infinite velocity. Infinite velocity. Infinite velocity. When a body is moving with infinite velocity, that is called the displacement versus time graph is a straight line. The displacement versus time graph is a straight line. It is parallel to what? Displacement. That is, such motion is never possible. This is the infinite velocity. Next one is when a body is sixth one. When a body is returns back towards the original position, original point with a uniform negative velocity. That means the displacement versus time graph is a oblique straight line. Oblique straight line. Oblique straight line. It is a the angle of the oblique straight line means that theta is greater than 90 degree. The theta is greater than 90 degree. That is the concept of oblique straight line. Oblique means when a body is returns back towards the original position. First to draw the displacement versus time graph. Displacement versus time graph. Then it is the meaning of oblique straight line means what is the angle? The theta is greater than 90 degree. That is the angle theta. There is the theta. That is the position of A, position of B. The body moves upward direction, again returns back. That means oblique straight line. The angle is theta. The theta angle is, that is a theta is greater than 90 degree. The displacement is decreases with the time till it becomes 0. Time till becomes a 0. That is a oblique straight line. This is the graphs of displacement versus time graphs. Displacement versus time. First, the body is a stationary. The body is a stationary. That means linearly or the linearly, or it is a constant. It is the displacement versus is a straight line. Second one is inclined. They inclined to the time axis. That means it is the direction of the body is, it is a 45 degree. Next, constant acceleration. Constant acceleration means it is a upward direction. It is a positive direction. Upward direction means it is represented by positive direction. And constant retardation. Constant retardation means it is a downward direction. Retardation, it is a negative direction. And infinite velocity. That means the particle of a body, it is parallel to the constant. That is means the body is moving with infinite velocity means the graph is a straight line. It is parallel to the displacement. Parallel to displacement. Last one is oblique straight line. Oblique means it is the body is travels. It is a final position and returns back to the original position. That means what is the angle? That is the initial position of the angle. That is the theta is greater than 0. That is the displacement versus time graphs. Displacement versus time graphs. Next is velocity versus time graph. Velocity versus time graph. Velocity versus time graph. How to draw the velocity time graph? Velocity, what is the meaning of velocity? It is a velocity is also it is a physical quantity and a derived quantity. The rate of change of displacement. The rate of change of displacement is called velocity. The rate of change of velocity is called displacement. Then first one is when a body is moving with constant velocity. Constant velocity. Constant velocity. That means the velocity versus time graph is a straight line. It is parallel to time axis. The constant velocity means the velocity versus time graph is a straight line or stationary. It is parallel to the time axis. First to draw the velocity versus time graph. The velocity versus time graph is the time along x-axis. The displacement velocity, not displacement. That is the velocity. It is also vector quantity. Derived quantity is the physical quantity is taken as y-axis. The fundamental quantity is taken as x-axis. It is the body is a stationary. AB is the body. It is this line. The constant line is it is parallel to the time axis. That is the constant velocity is a constant. That means the slope of the graph, it is the acceleration is 0. The representing instantaneous, the acceleration instantaneous acceleration is 0. This is the graph of when a body is moving with constant velocity, then the velocity versus time graph is a straight line parallel to the time axis. Parallel to time axis. Then second graph is When a body is moving with constant acceleration, the initial velocity is 0. Initial velocity is 0. That means the graph is a oblique straight line passing through the horizon. When a body is moving with constant acceleration. Acceleration means what? The rate of change of velocity. The rate of change of velocity is called acceleration. How to draw the acceleration velocity versus time graph? That means the body is moving with constant acceleration. The initial velocity is 0. That means it is the first to draw the velocity time graph. It is the position is called initial position, that is called acceleration. The acceleration is a constant. It is an inclined plane. That is a constant. It is a oblique. It is a 0. The acceleration is a the velocity is initial velocity is 0. Then there is a graph of velocity time graph of a constant acceleration. This is called constant velocity. Velocity is a straight line. That is the body is a straight line. This is parallel to the time axis. That is constant velocity. The constant acceleration is the initial velocity of the body is 0. That is constant acceleration. This is the velocity versus time graphs. Next one is last one is acceleration versus time graph. Acceleration versus time graph. Acceleration versus time graph. First one is when a acceleration of a particle is 0. The acceleration the acceleration is a physical quantity. What is the meaning of acceleration? The acceleration means the rate of change of velocity is called acceleration. The rate of change of velocity is called acceleration. When a acceleration of the particle, that is the acceleration is a derived quantity and physical quantity. The any derived quantity is taken as along y-axis, the time along x-axis. First the acceleration, the first graph is the acceleration of the particle is 0. The acceleration of the particle is 0. The acceleration of the particle is 0. That means the velocity acceleration versus time graph is the acceleration along y-axis, the time along x-axis is a acceleration is a 0. That means the acceleration is moving along a x direction. This is the initial position. The body is 0. Angle is 0. The body is moves 0 direction. That is the direction of the acceleration. That is a is equal to 0. A is equal to 0. That is the acceleration of particle is a 0. There is no distance. The acceleration is a 0. And second one is the acceleration is a constant. The acceleration is a constant. Constant means first to draw the velocity acceleration versus time graph. Acceleration versus time graph. The acceleration of the particle constant means that is stationary or linearly. As the body is A, B is the body. It moves a straight line. That means straight path. That means the acceleration is a 0. The acceleration is a 0. That is the acceleration is a constant means the body moving along straight path or linearly or stationary. That is the acceleration versus time graph. Next one, the acceleration versus time graph. The acceleration versus time graph. The acceleration is increasing. Third one is the acceleration is increasing. Acceleration is increasing. The acceleration is increasing means it is a positive direction. That means positive direction. That is a upward direction. First to draw the acceleration versus time graph. Acceleration versus time graph. The body is increasing. That means positive direction. Positive direction or upward direction. It is a, the body is a increasing. The body is a increasing. Next, fourth one, when acceleration is decreasing, the acceleration is decreasing. Decreasing means that is the downward direction. That is a negative sign. Sign is in the direction of the acceleration of the particle is negative sign. Negative sign. Time x-axis, the acceleration along y-axis, the body is a decreasing. Body is a decreasing, that is means negative direction, that is a curve shape, downward direction. Downward direction. That is the decreasing direction of the particle. That is acceleration versus the acceleration versus time graph is a decreasing, that is means downward direction. Next, fifth one is when the initial acceleration is 0, the rate of change of acceleration is not uniform. That means it is not a linear, not uniform. That means not a straight line, not a constant. When the initial acceleration is, the initial acceleration is 0, the rate of change of acceleration, that means the rate of change of acceleration, that is a not a straight line. How to draw the graph versus the acceleration versus time graph is, that is the initial position of the acceleration is a not is a 0. The rate of change of acceleration is a not a straight line. That means linear. It is linear. When the initial position of a acceleration is 0, the rate of change of acceleration is not a straight line, not a uniform. This is the acceleration versus time graph. Next, sixth one, the calculate the velocity, the acceleration versus time graph. The area enclosed between the acceleration time graph is a time axis. First to draw that is the area enclosed between the area enclosed between the acceleration versus time graph. Acceleration versus time graph. How to draw? There is the acceleration along y direction, the time along what? Time in y direction. It is the area of the acceleration versus time. This is the area of the acceleration versus time. This is the change in velocity from acceleration versus time graph. Change in velocity from acceleration versus time graph. These are the graphs of displacement versus time graph and velocity versus time graph. This concept is acceleration versus time graph. Acceleration versus time graph. Let's see. First concept is show this diagram. This is the displacement versus time graph. Displacement versus time graph. First one is the body is a stationary. The displacement along y-axis, the time along x-axis. The body is stationary means the rate of change of displacement, that is called velocity. The rate of, that is the body is a between the s and t, the body is a constant. Next one is when a body is moving with constant velocity. Then a body is moving with constant velocity. First to draw the displacement versus time graph. The velocity is a constant. That means the displacement versus time graph is inclined. Inclined means is a 45 degree. Next, third one, when a body is moving with constant acceleration, that means the displacement versus time graph is a curve with a bending upward direction. That is a upward direction. It is a positive direction. And the velocity versus time graph is a curve is bending downward direction. That is a That means the body is moving with constant retardation. Constant retardation. That is a negative sign. The axial retardation means the acceleration is equal to downward direction minus d, acceleration due to gravity. A is equal to minus g. When a body is moving with infinite velocity. Infinite velocity means the displacement versus time graph is a straight line. It is parallel to the what? Displacement. And the body is a oblique. The body is a oblique. That is, the body is a oblique means when a body is returns back towards the original position, that is the initial position, that is the final position, the body is returns back. And that means what is the angle? The initial position of the angle, that is the theta is greater than 90 degree. That means oblique. That means the displacement versus time graph is a oblique, is a straight line, and angle is theta is greater than to time with respect to time. This is the displacement versus time graphs. And velocity time graphs. First one is, first to draw the velocity along y direction and time along x axis. Velocity is a derived quantity, physical quantity. Time is a fundamental quantity. When a body is moving with constant velocity, that means linear line, straight line, stationary line. This is a velocity line. The velocity is a constant. Next, when a body is moving with the constant acceleration, the initial position is called acceleration. The acceleration is a constant, is a straight line. That means the constant acceleration, the initial velocity is a 0. The velocity time graph is a oblique. The acceleration is a straight line means the velocity time graph is a oblique straight line passing through the origin. This is the velocity versus time graphs. And next, acceleration versus time graph. Acceleration versus time graph. When the acceleration of the particle is 0, that is acceleration. This is called acceleration position. The acceleration is moving along the time axis. That is there is no distance, there is no value. That is the acceleration means that is a 0. The acceleration of the particle is 0. That means a is equal to 0. A is equal to 0. Next, when the acceleration is a constant, the acceleration is a physical quantity or derived quantity. It is taken along y direction, time along x axis. This is the acceleration particle. The particle is moving, it is stationary or constant or uniformly. Then when a acceleration is increasing, that means increasing means there is the upward direction. The sign is oriented by the curve. The direction of the curve is upward direction. That means positive direction. Next, when an acceleration is decreasing, the decreasing of the particle, that is the direction of the acceleration is downward direction, that is a negative direction. Downward, decreasing means downward direction or negative direction. When the initial acceleration, this is the initial acceleration is 0, the rate of change of acceleration is not a straight line. It is not a curve shape, that is a non-linear, non-stationary. The acceleration, the area enclosed between the acceleration and time graph. The area enclosed between the acceleration versus time graph along the time axis. That is the area of the acceleration versus time graph. That is called a area. These are the graphs between displacement versus time graph, velocity versus time graph, and acceleration versus time graph. That is the concept of graphs. And in next class is continuing to kinematic equations, the equation of motion in one dimension along a acceleration. That is the equation of a motion for uniform acceleration motions. That is called, there are 3 different equations: kinematic first equation, second equation, and third equation. The motion along a straight line, it is explained as three different equations, first and second, third dynamic equations. It is continue to next class. Thank you.